Hello students, welcome back. The topic that we are going to learn today is organization of data. In this part of the video, we will be looking at few of the example of discrete and continuous data and how to organize that data into group frequency distribution. So let's get started. Okay, now the example says that following is a record of sales of a shop on 50 days. Tabulate the data in the form of frequency distribution. Okay, so this is the given data. As you can see, the values are given listed here, all the records of sale of a shop on 50 days. So the total frequency is out here given is 50. Alright. Now this data particularly gave us a few information. First of all, the minimum observation in that data is 87. Now we can go back and look at the minimum observation. So here it is, 87 is the minimum observation that is given. The maximum observation, if we look at it, is 146. Alright, so the maximum observation is 146. Now if we find out the range means the maximum observation minus minimum observation. That means 146 minus 87, that is equals to 59. So this is my range. Now we need to divide this data into certain classes. Out here I have taken 8 classes. Now as I told you earlier that this is a pure own judgment criteria. We work on it, but the classes taken depends on our own judgment. We can take 5 classes, from 5 to 15 classes, but it's then up to us. We wanted to organize the data into 5 classes, or we wanted to organize the data into 7, 8 or any classes. Alright, so this number is on judgment basis. So out here I have taken my classes as 8, so k equals to 8. Now for height, according to the formula for height is equals to range divided by the number of classes. So height is calculated as range divided by number of classes. Range is 59. Number of classes that I have selected is 8. So if I divide these two numbers, I get 7.375. Now as you all know, and I have told you all before, that whenever any decimal point comes in height, we always take value higher than, we always move towards the higher value, a higher decimal point. Alright, so 7.37, the higher decimal point will be 8.0, so that is 8. So height out here is calculated as 8. Okay, now we will take the starting point as 87. So that is the one step that we are going to do, is that the starting point we took as 87. Why 87? Because 87 is the minimum observation in that data, and we will continue adding the height in each interval to get the lower limit of each class. See, these are all my classes. Since I wanted to divide the data into 8 classes, so these are 8 classes. This is my class interval. Now when I selected point 87, my minimum observation, then after that I will be adding 8, that is my height, into this number, so that I will be getting lower limit for all of my classes. Now 87 plus 8 gives me 95. 95 plus 8 gives me 103. 103 plus 8 is 111. 111 plus 8 is 119. This 8 is height we are talking about, and 119 plus 8 is 127. So on till 8 classes, that is 143. This is my final class, the last class that I have, that is class 8. The lower limit for this class is 143. So what I did initially, that I took 87, the minimum observation in my data, and I start adding height. Alright, and after that I get the lower limit for all of my classes, that is from 87 till 143. Okay, the next step is to find the upper limit. Now as you can see earlier, or if you just move back a little towards the data we have, this data is basically a discrete data. If you just look at this data is basically discrete data. Now discrete data means data that is given into whole numbers. So as you know that when data is given in whole numbers, we subtract 1 unit from the preceding values of lower class to find out the upper limit of the classes. Now how it is done, let's see. Okay, so 87 we just did this in the earlier step. Now we wanted to find out the upper limit. So upper limit is calculated by 95 minus 1, so that is 94. 103 minus 1, 102. 111 minus 1, 110. 119 minus 1, that is 118. So with every lower class limit we subtract 1 to get upper limit of the previous class. Alright, so this is how my classes are arranged. Now in the next step, in this step, what I have done is that using telemarks, I have calculated frequency for all the classes. Now for 87 to 94, if you just go back through the data, you look for from 87 to 94 that how many values are present in this range. I have looked at it and found out that there were 2 frequencies. Alright, so 2 telemarks, the frequency is 2. The set of values lies between 95 and 102 is 4. Then the set of values that lies between 103 and 110. Okay, these 2 values are included, 103, 110, 95, 102. So the values that lie from 103 till 110, the frequency I got is 5. Now from 111 to 118, the frequency is 8, and so on. I have calculated all the frequency for my classes. The total frequency, that is the summation f, is always equal to the number of observations given. Now if I add all these numbers, the result I got is 50. So that is how you organize a data into group frequency distribution. Alright, so this is basically you can also start your data, the organization, by using 85. I said earlier in my video that you always have to take the minimum observation or value before minimum observation. In this example, I took 87 first, then if I take 85 as my starting point and start adding height 8, so these are all the values that I will get, and with every corresponding intervals I get this following frequency. Now we are moving on towards the next example. It says the data given below shows the life of 40 car batteries. So these are the life of 40 car batteries. Now as you can see out here that all the data is in continuous form, it's in decimal points. Alright, 2.2 to 3.3, 3.9, 3.8, 4.1, 3.8, 3.1, 3.2 and so on. So these all values are decimal points value. So this type of data is called continuous data. Alright, and now we need to organize this data into group frequency distribution. So the initial process is same for both the datas. Alright, whether if it is continuous or it is discrete, the initial process of finding range and height and number of classes is the same. So let's get started. So this data gives us the following information, that is the number of total observations given to us were 40. Maximum value was 4.7, minimum value is 1.6, and the range calculated is, now range is maximum value minus minimum value. So range is equals to 3.1. Now I'm taking number of classes k as equals to 7. Okay, so height is calculated as range divided by the number of classes. So 3.1 divided by 7 gives us 4.443. Now we know that for discrete data, what we used to do is that we always take a value of the next higher whole number if any fraction values are given at the end, when height is specifically calculated. Alright, in this case, when the data itself is continuous and we are getting a fraction point, so what we are going to do is that we're going to move towards the next decimal point. Alright, so the next decimal point will be 0.5, or it's like rounding of this point into the next decimal point. So 0.443 will round it up to 0.5. Let's say if we have value 0.12, that will be rounded to 0.2. Alright, if this only works when the data given is continuous. So we know that in this example the data we are dealing with is a continuous data. It's in decimal points data. Alright, so height is 0.443. the next decimal point after 443 is 0.5. so the height taken is equals to 0.5. Okay, now I have taken 1.6 as my initial point. Alright, the starting for my first class, the starting point of my first class, and then I will be adding height for each interval to obtain the lower limit for each class. Okay, now from here on the process is same as of discrete data. Okay, now as you can see, I have divided my data into 7 classes. The first class is 1.6, 2.1. Now 1.6, if I just add 0.5 in it, the result is 2.1. If I add height in this lower limit, I will get 2.6. If I add height in 2.6, I will get 3.1. 3.1 plus 0.5 will gives me 3.6. 3.6 plus 0.5 gives me 4.1, and 4.1 plus 0.5 gives me 4.6. Now need to find out upper limit, and upper limit is calculated by subtracting from 0.1 from preceding values of lower classes. Alright, now what does that mean? See, I told as I told you all in my previous videos that whenever discrete data, whole number data is given, we subtract 1. But for continuous data, we subtract 0.1 from the preceding value of lower class to get the upper limit value of the previous class. Alright, so 1.6, we just already we did that in we did this thing earlier. Now we wanted to find out the upper limit for all the classes. So 2.1 minus 0.1 will gives you 2. 2.6 minus 0.1 will gives you 2.5. 3.1 minus 0.1 gives you 3. Now as you can see, the height of two lower limits and two upper limits are always same. It's 0.5. Either you just calculate this one value and start adding height, you'll get all the values, or you just subtract 0.1 from the preceding lower class to get the upper limit of the previous class. Now 2.6 minus 0.1 is 2.5. 3.1 minus 0.1 is 3. So both ways are correct. Either you do this or you just take out the first value and then start adding height, because we are dealing with equal class. Dealing with equal number of classes, the height of both lower limit and upper limit is same. So if you just subtract 0.1 from this class, from second lower limit of second class, and then find out the value for upper class, this is also correct, and the rest of these values can be added by adding height. So it is completely up to the person who is organizing the data. Alright, moving on. Alright, okay, so now when my classes are arranged Alright, it's organized. The next thing I did is that I find out frequencies starting from 1.6 to 2.0. This means that I have calculated, I have looked for all the values from 1.6 to 2.0 in my data and came across that there were only two observations present in this range. Alright, then for 2.1 to 2.5 the number of values present are 2. From 2.6 to 3 the number of values presented are 5. Now this column is up to you. If you're comfortable using telemarks, you can use this column. Alright, you can just mark down, just mark it and then write corresponding frequencies, or you can just directly write down the frequency. So this is completely up to you. Then 3.5 to 3.5 the number of telemarks are 15. See, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So the frequency is 15. For 3.6 to 4.0 the frequency is 8. 4.1 to 4.5 the frequency is 6. 4.6 to 5.0 the frequency is 2. If I just add all these frequencies, the total sum that I got is summation f, which is equals to 40. Why? Because the total number of observations I have were 40. So this is how you organize data when continuous observations are given and when discrete observations are given. I hope that you have understood that how can we deal with both kind of data. Actually both are same. The way of dealing both types of data is same. There's a slight difference between continuous and discrete is that finding out the upper limit. Alright, so I hope you have understood it. Thank you so much.